Okay. So last time we stopped here. We said after learning how to define functions, so when it takes like 11:20, you guys become crazy and then you leave the room, right? So that means we should start exactly 10:30. Good? Because you don't give me a room afterwards. So if we waste 5 minutes at the beginning, I have to take this back at the end, right? Okay. So last time we learned how to define functions. And we said the purpose of this is you want your code to be modular enough such that it's easy to manipulate and like give someone else easy to read later. And then we actually took one step further by saying you don't necessarily have to have all the functions on the same file, right? Because if you have hundreds of functions, which is usually the case if you have a good big project, then it's better to actually, how would you say this? It's basically better to organize it in multiple files. And then we said the way to do this in C, it's somehow similar to the way we utilize functions from the C library. We started our very first lecture by using the printf function from the studio.h, right? And then what I said back then is actually studio.h is nothing other than a regular C file, but it's included in the C library such that you can utilize the functions inside. So basically, what we do in our functions is exactly the same thing. You define your own header files, you define your own source code.c files, and then you do basically 3 steps, right? You define your prototype of the function in the header file, you define the body of the function or the definition of the function in the .c file, and then you include the header file in your main or whatever source file you want to use this function in. Good? So one example we covered is, assume I want to define my add and my sub functions. This is the body of the function, so I put in my math.c, and then I put the prototype of the function in the .h file, which I call my math_math.h. Something very important to know is these 2 files, the naming has to match exactly. Because this is how the C compiler would know that this prototype is actually belonging to this function in the same name.c file, right? If you name this my math without an underscore, and this is my underscore math.h, then you will never find, like the C compiler will never find this body of the function. What is the reason for this? The reason actually is because when you go to your, let's say your main for now, that you're going to include this function and use it, you are only including the header file, right? Not the .c file. How would the C compiler know that this header file is corresponding to this implementation? From the same naming. Good? So make sure that these 2 has exactly the same naming. Okay. I guess we have a problem with the AC, right? It's too hot right here. Good. So as I said, you define the prototype in the header file, you define the body of the function in the .c file, and then you include the header file in the place where you want to use this function. One example here would be calling the mysub with passing 2 parameters. Yeah. Would you say this again?
You only have one other file that does they have to have the same.
Yeah, that's true. If you can have multiple header files with multiple corresponding .c files, but you cannot have one header file for multiple like C files, right? So you have to have one header file, one C file for each basically number of functions you want to define. But on the same header file and C file, you can have multiple functions, right? Here in this example, we define 2 functions on the same header file and the same C file. That's okay because we put both under the naming of my math library, right? Your my underscore math.c library. Good? Okay. Any question? Those who are coming late, please like get seated quickly. We are already like past 7 minutes. Okay, so now this is when you define your own header files, your own functions, right? And what I said earlier, and like I'm going to repeat now, is actually the C library functions are nothing other than someone added some functions, exactly the way you define functions, and included this in the C library, right? Printf is nothing other than a function that does something, right? Correct? And then the only difference is that the C library compiler knows where these library functions are, right? When you set up your C compiler, those functions, those C library implementation functions are actually placed in a place where the compiler knows without needing to specify where I find my printf thing. Once you include, for example, studio.h, the compiler knows where studio.h is actually located, right? Because when you set up it, it's linked together, right? So some examples of things that we can utilize: math.h, string.h. String.h is specifically important for C, not C++, because in C we don't have a natural type that is of string, right? We have a character, we have an integer, double, float, but we don't have string. And some of you asked me, what if I want to define a variable that is something like this? I'd say x equal, I don't know, like hello, right? Or I don't know, 2sh4. This cannot be defined as a character, right? Because you have multiple characters here. You actually have 4 characters. So you need a byte for each. So this cannot be a character. There are multiple ways of dealing with this in C. One of them is to actually use the string.h helper functions there to implement a string. And we will see this later in details in a separate lecture. Another thing would be, can someone think of something else that I can use such a thing without using a string.h for a bonus function? For a bonus mark. Let's hear from someone else, right? Yeah? Store it in an array, right? So define, please give me your name after the dictionary and you do the same thing, right? So a string is nothing other than multiple characters together. If you want to link them, I can actually kind of detour the problem of not having a string by saying a string is nothing other than multiple characters together, and then you define this in an array. So what you can do is you define an array of characters. Here you need 4 elements, right? So you'd say 4, but let's say I call this x in this example, then say 4, and then you initialize this for something like 2, then s, and h, and then 4, right? These are, as I explained last lecture, because this is an array, they are placed together in the memory, so they are consecutive like this in the memory, right? Then you can use them together. I just did one small mistake here. Can someone catch this for another bonus mark? Yeah? Did you say anything and I didn't hear, or you didn't say anything? Yeah, like, but this is not the thing that I'm looking for. You can have a semicolon. Thank you. Who said that? And the reason?
The reason is there needs to be a string terminator.
Yeah.
So it's space for that.
Exactly. So basically, a string in C has to end with what he said, a terminator thing, right? Like you have a special character here that is null, basically, that terminates the string. And this is another character. So if you have a string of 4 characters, you should actually add 1 extra one, right? Please give me your name afterwards. And afterwards, like, don't answer without raising your hand, okay? Yeah, I should select you first. But anyway, give me your name afterwards. Thank you. Okay, we'll actually come into this later in a separate lecture. but basically there are multiple ways to deal with the strings in C. Good. One of them is including the string.h file. Good. We already dealt with the studio.h. That's good. Okay. So these are some example functions from these header files. For example, these are from the math.h. You have a square root, you have a cube root, we have exponent, log 10, absolute, power, sine, cosine, different math things that you can actually use. I have actually uploaded this lecture into Avenue, so you guys don't need to take screenshots or write anything. It's already there in Avenue, right? Okay, so these are some of the functions that you can utilize in your code, right? Unless you are asked not to do so. For example, in Lab 1, you are asked not to use something other than the studio.h, I guess, in some questions, right? So that means you are not allowed to use these functions if you are constrained not to do so. Good? But in general, it's okay to use any of the C library functions. Good. So another thing that is very important and it's related to functions. Is there any question first? Good. Okay, so another thing that is related to functions, we touched on briefly yesterday, is basically local versus global variables, right? We said, you remember this example of, I guess, square mean function, where you had x and y and z, and we said once you enter the function, x and y and z get allocated into the memory, but once you exit the function calling, these are destroyed from the memory. That means the persistence of these variables in the memory are only within the execution of this function. Why? Because they are defined within this function. These are called local variables for this function. Local because they are only defined and used within this function, and once you leave the function, they are no longer exist. Good? On the other hand, global variables you can actually use in any function. And we will see how to define this now. Basically, you can use this in the main, you can use this square root, add, sub, any function, or actually these variables are visible to this function. Good? So one example of a global variable is if you define a variable that you call by, which is float, 3.14, outside the main and outside of any function. This by you can actually use in any function because you didn't define within a specific function. You defined outside all functions, and any function that is within the same file, the by is actually visible to this function. Good? On the other hand, m, you only define m within main. So if you have another function here, my square root, for example, you cannot use m, right, without defining it, because m is not visible to other functions. Right? And you can actually try these things yourself. You can open a main, define another function, and define some variables within each function and see whether you are able to call some variables within the main into the square root or the other way around. So you can check local versus global variables yourself. Right? Good. So the way to define global variables is actually to define them outside any function, right? So these are called global variables. Why actually defining global variables is not recommended? Can someone let me know why? Yeah? You said it like you are in the correct direction, but you said actually the completely opposite thing. Right? Basically, global variables, they are visible to any function, right? That means you can read them and modify them within any function, right? And that's actually very risky, right? Because maybe, assume that you define a variable that's called x. It's a global variable. You use it in 10 different functions. Any change to x in any of these functions will reflect in other functions. You may actually intend to do so, right? Maybe there are some cases where you want this variable to be used across everything, and one change in any function will reflect in the others. In this case, that's okay. But in general, that's not preferable, right? Why? Because first, it's risky. Maybe you change the variable in one function and you don't intend to actually reflect in another value, and you get a wrong answer. Another reason why global variables are not good to use in general. Yeah? Yeah, and that means you waste your memory, right? Because they are global variables. Remember we said local variables, the x and y example in the square root function, they are only allocated in the memory once you enter the function, and once you finish the function, they are destroyed, right? That means they exist in the memory, they book or reserve a place in the memory only when you need them within this function. Outside the function, they don't exist. If you have very limited memory, right? If you define many global variables, that means they exist in the total duration of the program, even if you don't use them, right? So for example, global variable you use in 2 different functions, but you have hundreds of functions. No matter which function you are executing, these variables actually exist in the memory. That means you are wasting, if it's an integer, you're wasting 4 bytes, even if you don't use them, yeah? So what do you think? Like if 2SH4, does 2SH4 include the lab or not? Right? I leave this to you, right? So you can actually come across, so I said, okay, maybe I need to reflect a variable within multiple functions. This is actually a valid use case. How would I do this without global variables? Can someone find a way? Yeah? And then pass this variable to it. So that's a valid point. Basically, if you need to pass a value from a function to a function, don't use this through global variables. Use this by returning a value from a function, right? What if, so each function, we have one limitation. Each function has only one return value, right? What if I want to actually reflect multiple variables, return multiple variables from one function? What can I do? This is like a little bit advanced question. Yeah? Yes. Okay. This is one possible solution. Thank you. Yeah. No, you cannot have this. You can only return one variable, right? And this is a problem. So one possible solution, he said, you can actually return a pointer to an array, right? This is even a more advanced function than what I hoped for. There was a little bit possible solution that I discussed yesterday. You remember we said when passing parameters to function, you have 2 possible ways, right? Passing by value, good, and passing by reference. We said in passing by value, remember the a and b and x and y? We said a and b don't change in the main if you change x and y in the my square root function. And the reason is actually you only pass the value of a and b to x and y, you don't pass the storage itself. And we said there is another type of passing variables, which is passing by reference, where actually a function gets access to the variable itself, location, right? If this is a case, and then you have, so yesterday we had this, we had a is pointing to a place in the memory, b is pointing to another place, and this is in the main, and this is your function, right? Then we said x and y, it takes 2 variables. Then we said what usually happens if you call function by a and b, they will get passed to x and y, right? So the copy, like the value of a will be copied to x, the value of b will be copied to y, right? Good. And if you change those, yesterday we had the example of, I guess, 10 and 20, and then we squared x, so this got 100, and then we squared this got 400, I guess. But a and b didn't change if you change x and y, right? Because these are separate locations in memory. This is pass by value thing, which is the natural thing, which is by default. But you can pass a parameter by reference, which means you call this function by saying, I pass the address of A and address of B. This function will get access, now we don't have these things, this function will get access to the A location itself and the B location itself. So if you change A and B inside, or now there'll be X and Y corresponding ones, you are actually changing A and B itself in the memory. That means you can reflect the change in multiple variables on the function using pass by reference, right? Is this complex? Not very clear? Again, we'll come into this later in more examples, but just put this in mind. Okay. So here, another example for global variables and local variables. So I define, this is a complete file that we define. We include studio.h. We have a prototype for a function that we call square. It takes no input, and it returns a double. And then we define a global variable that we call double alpha 1.5. And then inside the main, I actually call the square function, and then I print a. What square is doing, this is the body implementation of square. I just square the alpha variable, right? So you square the alpha variable, what would happen is it will get 1.5 square, and then when you print a, it will be 1.5 square, right? If alpha is actually local to main, instead of being global, and you do this, what you expect, you would get an error, right? Because inside this function, alpha is not defined. Now it's actually not a global variable. It's a function. It's a variable within the main. So you cannot use in another function. Does this make sense? Yeah? So these are some of the rules that we'll take more examples later for them, but basically these are the theory behind the scopes of the variable definition. So file scope means any function within this file is able to access such variables. Global variables are within file scope, right? That means any function within the same file will be able to use this variable. Function names, by default, actually a function is a global thing because you define a function to be able to use it in another function, right? So it should be global by nature. Block scope. Block scope, which is if you define a variable within one block, you can actually only use this variable within this block, right? This is even more strict than defining a local variable within a function. So let's see one example, right? Let's say I have a main, and then I define a variable that is called x here at the beginning of the main. What is the block of this variable? It's the main function itself. So anything within the main, you can actually use x, right? Assume now I did something different. I said for int I equals 0 and then something, right? Now you define a variable that is called I for your iteration within the for, but you define it within the for block, right? So once you are done with your for, if you say, for example, here I equals 3, you will get a compiler error. The reason for this is the definition of I is within the block of the for. You cannot use it outside the for. Inside the for you cannot do, inside the for you can do whatever you want with I because it's already defined within this block, right? So it's not by default that if you define a variable within a function anywhere, it can be used anywhere in the function. That's not true. If you want to use the variable anywhere in the function, then what you should do is to define it at the beginning, right? Within the scope of the function itself. Then you can use it anywhere. Otherwise, if you define it within a block, then you are restricted to use this variable within this block only, right? Is that clear? Is there any question? Okay. So these things are basically more of a theory thing. You know this by nature. I don't want to confuse you, so you don't even need to think about it. So the storage duration, we already discussed this when we talked about local variables. Global variables are maintained in the memory during the execution of the program. Local variables are maintained in the memory only within their scope, right? So for example here, x will be in the memory once you are within the main, right? But I is only defined when you enter the for, and once you finish the for, it's actually get destroyed in the memory, right? And this is one good reason why, for example, if you use I for iteration, it's good to define it within the for, not outside the for, right? Because first of all, it will prevent like using I for different purpose. And the other thing is you save some space in the memory because you need I here only for iteration. That means there is no point of keeping it outside the for, right? Yeah. Would you raise your voice, please? Yeah, it's allowed. Yeah. Because if you remember when we discussed for loops, the first part of the loop here is actually an expression where you can initialize your variable. Yeah.
The thing is, if you're using GCC as a compiler, and it doesn't allow you to do that, and versions for C, it's only allowed in C99 or C11.
So this is the 89 version that is not allowed, and specifically for the GC compiler. Yeah, so what your colleague is saying is actually the oldest version of the C. I don't know about other compilers, but in GCC, this is not allowed, but in 99 and afterwards, it's allowed, right? So right now, it's allowed in C++ as well. So you can say it's okay, right? Good, thank you. Another thing that is more advanced than just local and global automatic duration. What if you want intentionally to keep a variable in the memory within the execution of the program, even if it's a local variable? I don't know why you may need this for now, right? We don't have a use case for now. We'll come into it later. But you can do this by using the reserved word static, right? So here we said int x will be placed only within the main. Right? Let's say I have another function. This is a better example. And then you define int y equals something, right? That means by nature this is a local variable. It will only get defined in the memory once you enter the function. It will get destroyed here, right? What if you don't want this to be destroyed? We have the reserved word that is called static. And the purpose of this static thing is you tell the compiler, I don't want to destroy this variable. I want to keep it in the memory during the execution of the program. Good? So using static is actually very confusing for multiple things. Static makes the variable existing in the memory during the execution of the program. Good? But it doesn't make it global. You see the point? So it will exist in the memory during the execution of the program, but you cannot access it from anywhere else, because it's not a global variable. It's still a local variable, but exists in the memory. Good? Do you see what I'm trying to say? So static only controls the existence of the memory, not the access of the variable. Good? So you still cannot access y in the main. But the point adding static what will happen is that the compiler will not destroy y here. By nature, if we didn't have this, y will get defined here and destroyed here. If you use static, if you exit the function, y will still be in the memory. Good? And these are some rules of doing static things. Basically, I said in the first lecture, I guess the second one when we discussed variables are not initialized by default in C. So we said if you access a variable without initializing it, you will get any garbage from the memory. But if you define a variable as static, it's initialized to 0 by default. And the thing is, static variables exist all time in the memory, right? Good. This is an example of using a static variable, similar to the one that I defined here. Basically, you define a static C, static, and this is one possible implementation of why you need static, right? Assume here this function you call once, right? So here we call it from a loop. In the first iteration, when I call function A, I go there, you define a variable that is C. By default, it's initialized to 0, and then you increase this and this. This is 1, and this is 1, right? Let's go actually to see what happens, right? So in the first call, I go here, I initialize B to 0 and C to 0, right? And then you increase B++, C++. So in the second iteration, you are supposed to actually find B as 1 and C as 1, right? You return 1, 1, and then what is the value of A? It's 2. So you should return 4 in the first call, right? Do you follow? The difference of a static thing comes in the second iteration. When I go to the second call, which is the second iteration here, again I initialize B to 0. But the thing is, YC is 1 here. Yeah? Exactly, because it's a static variable, that means it maintains its memory storage from call to call, right? From the previous iteration, from the first call of the function, you defined C as a static variable. Good? And it has a location in the memory here, and you increased it by 1, right? So it gets 1. If you go in the next iteration, and this is B, assume this is B. This is a static variable, right? This is non-static variable, so it's a local variable. From the first iteration, once you are done, this gets destroyed. It was actually 1, so it gets destroyed. And this is not, because it's static. If you go to the second iteration, this still maintains its 1, but B gets redefined and initialized to 0, right? This is why you find in the second iteration, actually B is 0, C is 1, and then you get the different result. In the third iteration, again, B is initialized to 0 because it gets destroyed and then redefined. But C maintains its original value because the place exists in the memory all over, right? And then now we increase it from 1 to 2. This is why in the third iteration, it has a value of 2. This is one possible way of why you may need static variables. If you know you have multiple calls to this function, right? Then you can actually utilize this variable, and we'll come into this actually when we talk about recursion. Maybe you have a function that calls itself multiple times, right? Then in this case, in some possible scenarios, you may need a static variable. Is there any question? Yeah? A1 is not defined. A1 is actually, this is a good question, because A1 is the input parameter to the function. So input parameters to functions are also local variables to this function. So they are defined within the scope of function. Here, function takes an input A1, right, which is int. That means you can use A1 within this function. And A1 gets the value of what is the input to the function, which is A here. So what happens is we have a third variable that is called A1. And when you call function from main, A value will be copied to A1, similar to the AB, XY case that we have here. Is it clear? Right? So the input parameters to the functions are local variables to this function. And you get their value from when you call this function itself. So A will be copied to A1. The value of A here is 2. Right? That means A1 will get 2. If you add this, in the first iteration, it's 2 plus 1 plus 1, 4. Right? Did this answer your question? Any other question? Good. So something that is very important is, as you can see, the more we go into lectures, the more information I'll throw into your minds, right? And if you don't actually apply this, and maybe, for example, you wait until lab 2, which for some of you will be after 3 weeks, you will forget all these things. And there are so many tricks for that, right? So you should actually try to implement the programs in the lecture yourself, see different scenarios, see the things we discuss in the lecture. If you define something as global, local, static, non-static, what would happen, right? And also, I post some exercises and avenues. Make sure you do this as well. Otherwise, you will forget all of this. It's confusing if you don't get your hands on, right? Any question? Good. Okay. So this is something that is optional if you'd like to know this. You remember we said you can have a program or a project of multiple files, right? Something that no one asked me about, and actually I was expecting a question, is we said global variables are within the scope of the file, right? So if you have one file, let's say program.c, you have main and like hundreds of functions, and you have one global variable, you can use this global variable within all these functions. But on the same lecture today, we said you can define your functions in multiple files. Can a global variable be accessed from those other files? The answer is no, by default. If you want to do so, then you need to use the external word, right? And actually, what would happen is, first of all, static cannot be called from another file, so a static variable has to be within the same file. So you cannot use static with this case. But you also have to use the reserved word extern, which basically initiates a link between this file and this file. So assume in one file you defined a global variable that is by, right? 3.14. You want to use this variable in another file. What you would do is say extern int by 3.14 or another value. The word extern would tell the compiler when you come to the linkage stage. You remember we said the linker will link multiple files, right? It will tell the compiler, this definition of this variable actually exists in another file, so don't redefine it. And then it will link both together, right? Good. Okay.